Hello everyone, welcome back to you in a new lesson in Algebra 1. Today we will discuss together what I mean by rational expression and just as introduction for it. So at the beginning, let me start by a definition here. So what I mean by rational expression, we know rational numbers, it is a class of real numbers. But what I mean by rational expression is just an expression. It's a fraction contains a polynomials, or a rational contains polynomials up and down. So a rational expression is a quotient of two polynomials. Its domain consists of all real numbers for which the denominator is not equal to zero, and that is a necessary condition, by the way, for anything, for all quotients, for numbers or expressions. So if we get back for the functions, we need to determine what's the domain. So the rational expression, if we deal with it as a function, we need to know what's its domain. So domain, it's clearly, it will be all of the real number except when the denominator is equal to zero, because it is prevent. So this is what I mean by the definition. That summarize all of this definition just in this simples. I will apply some example later. Now, these values, when the denominator is equal to zero, the special values, these where the function is undefined, or the expression as undefined operation here as a fraction or as a ratio, or as a rational expression, then these values we will call that excluded values. Excluded values. So what's the excluded values? Is the values where the denominator is equal to zero. Now let me give you some examples. Let me start by the first example here. First example, we have a rational expression contains 3x plus 2 as a linear polynomial upside, and 2x plus 4 here as in denominator. So what's the formula for the domain here? The formula for the domain, to find the domain, the question asks you to find the domain. So what's the domain? The domain is all of real number except just these value when the denominator is zero. This value we call it excluded value. So what's the denominator here? The denominator is 2x minus 4. So I need to copy it and paste it here. This is 2x minus 4. Now this is a linear equation. We need just to solve it. 2x minus 4 is equal to 0. We need to move this negative 4, cut, and paste it here. We will get 2x equal to 4. Now if we divide both sides of this linear equation over 2, we will get x equal to. That's meaning that the main of this rational expression is all real number except x when x equal to. If I want to graph it, that's meaning x don't equal to. If we get back for the inequalities from chapter 1 and chapter 2, the graph of inequalities is represented by this shape or this form. So this graph represented x don't equal to what we need, or real number, just x. We don't need x equal to because it is excluded value. So I will exclude it from this, the number line, as this open circle. We will get here, this is the graph. Now represent the formula here from the roster notion here as the interval notion. The interval notion, it will be represented by from negative infinity up to 2, union from 2 up to infinity, and both sides at 2 are open. You need to be careful for that because 2 is excluded. So the excluded value is 2, or we can say just x don't equal to as a simple. Another example. Now, the first one was both both expressions in denominator and numerators are linear. So what becomes if it is not linear? Cubic, quadratic, no important. All of these polynomials, we deal with them in same procedure because we can factorize up to now. We can solve any quadratic equation and a cubic equation. So what's the problem here? Let me start. So if we have this rational expression, we need to factorize it. We need to put the formula first. This denominator is equal to 0 when? We need to find when the denominator is equal to 0. So I will pick this my x squared minus 8 here. And now I will start factoring. I will start this with you together. So I will open two brackets. The first bracket will contain x and x. Now we need to search about two numbers. Their product is equal -8 and their sum is equal -2. What's this product? Of course, they are -4 and +2. If you don't understand what we do here, you just can get back for the factorization lesson. Good. Now, x minus 4 times x plus 2 is equal to 0. That's meaning by principle of product of 0, it's meaning one of these brackets is equal to 0. So x minus 4 is equal to 0 or x plus 2 equal to 0. In this case, if x minus 4 is equal to 0, that's meaning x equal to 4. Or if x plus 2 equal to 0, if we need to move to the other side, it will be -2. This is the value of x. So all real number except 4 and -2. How we can rewrite this as interval notion? Of course, we will write it like this. I will start from -infinity at the beginning of my number line up to the first negative number, which is here, or at the beginning here, not necessary to be a first number. The first number I face it here, which is -2. I'm moving from left to right on the number line. Imagine that. I will get back here for the graph. Imagine that you start from here and you move from left to right until to reach the first one you find it here, which is -2. Union. I will start indexing here from the end of the last interval. So here it will be. I will start from -2 up to. Now I will get 4. Another union. I need to cover all of number line. Another union from 4 up to infinity now. Now we cover all of the number line. We have covered all of the number line by this interval notion. So we can represent the domain by the roster notion in this case, or by the interval notion as you want. Another type of question we need to discuss it today, which is how we can simplify. Now we learned how we can find the domain. Now how we can simplify these rational expression. By the way, it's easy. Just you need to two steps. The first step, we need to factorize the denominator and search about some bracket can cancel it. So let me start. So if we take 9 minus x squared, it will be 3 minus x. If you don't remember how I can factorize these, just by difference between two square formula here. A difference between two squares, it's give us 3 minus x times 3 plus x. Because we have 9 is a complete square, x squared also is a complete square, so we have the case of difference between two squares. Now the denominator here, it will be, if you focus here, you will find it is a complete trinomial here, a complete square trinomial. So this, it will be like this, x plus 3 times x plus 3 itself, or we can rewrite it as x plus 3 square as you want. but I prepare this shape now to cancel this number. I will highlight it here by another color. So this x plus 3 is gone with x minus 3 here. Our also is done. So these values x plus 3 and x plus 3 cancel each other. Finally, we will get the last answer, which is 3 minus x over x plus 3. By the way, the first form here, let me return this to its general form. Now, this form is called a factored expression form. This is the original form of the equation. This is the factored expression. This is the simplified expression here, this case. This is the last answer. Now, if I asked you to find the excluded value, from where you get it, you need to remember this very important note here. To determine the excluded value, you need to find it from the factored expression, not from the simplified expression. So you need to find the excluded value before you cancel terms here, okay? Before you cancel factors. You cannot cancel, then find the excluded value, because you will get a wrong answer. So in my case here, the excluded value, not just negative 3, it's negative 3 in my case, because here is identical, positive 3, positive 3. But in next example, you will find that it's not necessary to be equal. Done. Okay, let me give you an example now. So if we wanted to solve, if I change this to be negative x plus or minus 6. Okay. So now what's the excluded value? What's the simplified form? What's the simplified form? So I will take this as a copy paste here to save the time by writing here. So this is a negative 6. Here a negative x. I just rearranged the first question. So the denominator here, I didn't change it. The denominator, I have changed it to p. Now the factoring, it will be x minus 3 and x plus 2. You can see that x minus 3 with x minus 3 minus x, they cancel each other, except we will get a negative sign here because they are different with just a little different sign, because the denominator or denominator, if you multiply it by negative sign, you will get the other here. So I will put here just a negative sign for the negative 3i minus x. And here we got x plus 2 as my answer. Yes, here is 3 plus x, sorry. So this term, let me highlight the terms which is cancelled here. So the terms cancelled each other, this one and this one, they cancel each other. Why? Because they are identical, just the difference because it's a negative sign here. I put it. So we will get the final answer as negative this bracket 3 plus x over x plus 2. You can simplify it to be negative 3x, negative x, negative 3, negative x. Good. So what's the excluded value here? the excluded value is just -2 or 3 and -2? Of course it is, they are 3 and -2. These excluded values, remember that, don't cancel, then find the excluded value. Okay, what's the domain also? The domain, can we say the domain is all real number except -2 or except -2 and -3, -2 and +3? No, in my case, I will just look for this term. This is the simplified form. We cannot use it even in domain or in excluded value. You need to remember that. So in this question, the domain, it will be all real numbers except 3 and -2. Just in my case, these excluded values. We complete our lesson today because I want the video to be short to make it, to kind see it. Now the homework for you, it's we need to simplify and factorize these rational expressions to find the simplified form. Also, I need from you to find the excluded values and the domain of these rational expressions. If you face any problem, please don't hesitate to contact me anytime. Thank you for your watching and goodbye.